In programming, there are math symbols that we use to do mathematical functions. So we're going to look at the consistent ones, we'll look at division, and then we'll look at what are known as shorthand. So there are three consistent symbols used throughout different programming languages. And apparently I cannot spell consistent. It's ENT. So you learned something else today. The plus sign, can I get this to be pink, please? Thank you. I can get all that to be pink. Cool. The plus sign stands for addition. So an example of this would be 5 equals 3 plus 2. And actually, I don't want to do that because you'll see why later. The minus sign is subtraction. So 3 equals 7 minus 4. The asterisk, which is again the key above the 8, is for multiplication. That's what you always want to use. If you use the letter X, it's just going to mean the letter X, and the program will not like it. So 36 is equal to 6 times 6. Pretty simple. These are the three consistent math symbols used throughout programming. Division in Java is actually a lot simpler than it is in Visual Basic. Again, we're focusing on the dividing of integers and doubles, numbers with decimal places and numbers without decimal places. Integers being the numbers without decimal places, doubles being the numbers with. A double is really simple. It's the way we traditionally think of doing math. So, for example, if I'm taking 4.6 and dividing it by 2, it's going to equal 2.3. We use the forward slash all the time when dividing. Not a big deal. And decimals are always going to come out. If it's a whole number, it's just going to put the 0.0 in there. On the other hand, though, in Java, if we use an integer to divide, it's going to always round down. Now, this is going to become really key when we're working with conversions, doing different things of numbers. We're going to do some coin conversions, some different programs like that. Let me show you. Let's say I'm taking 7 and dividing by 3. The number is actually going to equal 2. Because in reality, I'll prove it below it, 7 divided by 3 is equal to 2.333. It takes that 333, drops it off because it can't have a decimal, so it only keeps the whole number. Another example of that would be if we take 8 and divide by 3. Now it's going to equal 2. It's still going to equal 2, because in reality, 8 divided by 3 equals 2.6666, and keeps going on forever and ever. But again, it drops off the decimal place. And then the third example, 9 divided by 3 as an integer, of course, comes out to be 3. So integers are always going to round down in division. Now, there will be instances, though, where after it rounds down, we still want to collect the information from the 0.333 or the 0.666. We're not done with that data. That's when we use the percent sign in our math to pull out the remainder. So example, going to go down here. I'm going to do the exact same example. 7% sign 3 is actually going to equal 1. So let's think back to when we did elementary math where we did the remainder before we ever did a decimal place. 7 divided by 3 is equal to 2 with a remainder of 1. So that's where that 1 comes from. I'll pump through the rest of the same example. 8 If it'll let me type, there we go. 8 divided by 8% 3 will equal 2. Because again, it's pulling the remainder. 8 divided by 3 equals 2 with a remainder of 2. So there's where that 2 is coming from. It is possible, if we do 9 divided by 3, which equals 3, remainder 0, that real simply, we will just have a number with a remainder of 0. 9% sine 3 equals 0. And that's okay. There is absolutely nothing wrong with having a remainder of 0. That just means there's no data left over for the next step that we want to work with. Pretty simple. Shorthand operations allow us to abbreviate code and make it easier to work with. Once we get into some of the more complicated code, we're going to really like shorthand operations in the sense that it'll take longer math equations and shrink them down a little bit. We're going to use the example of coins from, let's say, Super Mario or Sonic the Hedgehog, where we're collecting the coins. This is also the same way for those who are into Call of Duty and those kind of games that your bullet counters work. Same math behind it. So, I'm going to use coins though, since we're in a school environment. And I'm going to change my color here a little bit. Let's change it to yellow. Yellow coins. Okay, cool. So let's say with the coins, if you'll let me type, there we go. My coins variable starts off at 20. My integer coins is 20. And I run into a new bag of 50 coins. I could type it coins equals coins plus 50 because I'm adding another set of coins to what I already have. But a quicker way to write that, and especially if we're doing a lot like in a game where you're either deleting a lot of coins quickly or adding a lot of coins or bullets quickly, this is the better way to do it. Coins plus equals 50. This will do the same math, get us to equal 70, but much quicker. This is known as the shorthand operation version. And we can do the shorthand with all the math functions. So I'll show you these real quick. I'm going to do them in green. I'm going to pause real quick. And I'm back. Thank you, Mr. Zach, for that interruption. We're going to show you the different shorthand operations, what they look like. So, if I'm doing addition, it is plus equals is addition. So if I want to add to the same variable or subtract a new value to change the value of the current variable, I would do plus equal for addition, minus equal for subtraction, asterisk equal for multiplication. Remember that we use the asterisk for multiplication. For division, we're going to use the / equal for division. And then for remainder, we're going to use the % equal for remainder. So the actual logic behind it is pretty simple. However, it takes a little bit to get used to. So what we're going to do in some of the coding problems is we're going to emphasize when we're adding or subtracting a new value to a variable that this is the way we do it. Because on the AP test, this is the way it's going to show up a lot.